afternoon. We're going to review Chapter 30 out of your textbook. This is a basic review of welding symbols. For those of you that go on and take welding inspection technology, we're going to get into this a lot more thoroughly. But at the end of this lecture, I'd like you to continue watching and watch the training film that we have on welding symbols, because it will help to explain this stuff in greater detail than what we're going to cover right here. So listen to this lecture, and then you have about 40 minutes after this lecture of training films that will go into more in depth. So I'm on page 1103 right now, and let me just draw your attention to the board here. This is the ANSI AWS A2.498 standard symbols for welding, brazing, and non-destructive examination. Everything that we talk about will come out of this text. The portions of that text that you need right now are already in your book. But let me read from the top of the column here on page 1103. It says, "The following material has been developed by the American Welding Society and is being reprinted here through the courtesy of that organization." In that same paragraph, put a bullet by Standard Symbols for Welding, Brazing, and Non-Destructive Examination, AWS A2.4.98. You'll need to remember the name of that text because it will probably be on your test. Then drop down to the bottom of the column, and I'm reading from your book here, and it says, "Welding symbols give complete welding information. They indicate quickly to the designer, drafters, production supervisor, and the welder which welding technique is needed for each joint to satisfy the requirements for material and strength service conditions." It says figure 30-1 shows the basic components of a welding system. We'll get to that in a second. If you look at this, a welding symbol is a shorthand method for conveying welding information, and you can put an awful lot of information on these symbols. The AWS system is used all over the world, and it is modified as necessary to reflect needs of industry. It's a very simple but a very powerful system for conveying information. Once you learn how to read it, when you first look at it, you think, my God, that's really complex, but it's not. It starts with the basic elements, and the required elements are a reference line, which is always horizontal, and then an arrow. So let me draw that on the board for you real quick. Really simple. If you have got a welding symbol, every welding symbol has to have a reference line, because your information is going to be placed on this reference line. And every welding symbol will have an arrow, and the arrow points to where the joint needs to be made. So let's say, for example, we had a T-joint. Okay? So we're going to have a T-joint, and we're going to have that T-joint, and we're going to put a fillet weld on it, just like you've been doing in Weld 1755, 1760, Weld 1950. Those are all fillet welds. Well, if I put my fillet weld symbol below the reference line, that means that I want this weld made on the arrow side of the joint, right here. If I put a fillet weld symbol above the reference line, it means that I want the fillet weld made on the other side of the joint. So already we've got some useful information put in there. I'm not going to go any farther with that right now. Let's go back to our slide, and let me show you some of the other optional elements. Those are just some of the basic elements that I put on the board, but you can have multiple reference lines. You can have a tail that goes onto the end of the reference line. The weld symbol, I drew a fillet weld symbol up there. Then the dimensions, I didn't put the dimensions of the fillet weld in there, but we'll do that in a minute. Supplementary symbols, what type of finish do we want on it? Any specifications or type of process. All of that information can be placed on a welding symbol. Now in your book on page 1104, figure 30-1 shows those basic elements that I've already drawn on the board. It shows an arrow and a reference line. And remember, these are the two most basic elements that you have to have. Then it shows the other side and the arrow side. And here's the same figure I drew on the board. Here we have a T-joint, arrow side, and other side. And it says information applicable to the arrow side of the joint is placed below the reference line. Information applicable to the other side of a joint is placed above the reference line. So here we have arrow side, other side. Here we have a square groove, square bevel groove joint, and since the welding symbol is above it and it's pointing here, this becomes the arrow side. The other side then would be back down around here. Here are some welding symbols that are drawn on the arrow side of the reference line. Here's the fillet weld symbol that I just drew. This would be the symbol for V-groove butt joint, and this would be the symbol for a J-groove butt joint. I want to draw your attention to the arrow here. See, here we have a straight arrow, and here we have a straight arrow, but here this one has a break in it. If you go back to here, say this arrow had a break in it, then that arrow would point towards whatever one of these members we would want to do any finishing on. Here we have other side symbols. Again, we have a fillet weld, a V-groove, and a single J with the break in the arrow. And if you have a single J, one end of that single J is going to be straight and the other end is going to be prepared. Well, you don't know which side has to be prepared unless you look to see where that arrow is pointing, and then the break in the arrow says, hey, look at me, this is the side I want you to prepare. Side significance. Now some weld symbols have them just like this. And so here we have a resistant spot weld, a resistant seam weld, and a flash weld. So it says the weld symbol straddles the reference line when there is no side significance. It doesn't make any difference because there's no side for you to have to worry about. And those are applicable to resistant spot welds, resistant seam welds, and to flash welds. There's also others. And you'll notice that in the tail, they put RSW, so that they put additional information in the tail. And that's what the tail is for, to put information in there that you might not otherwise be aware of. And again, here's the tail. And it says the tail is used to specify welding process information or other such information needed to convey the necessary welding details. So here we have GTAW-AU. So that's gas tungsten arc welding automatic. So it's telling us how it's going to be welded. How is the weld going to be made? So here they want us to do it with TIG, automatic TIG instead of stick. Down here it says TYP-5 places. TYP stands for typical. Typical in 5 places. So if we had a fillet weld symbol here and a dimension mark, we would know that they want us to make a fillet weld, half-inch fillet weld, whatever, in 5 places. Now, arrow side, other side, and no significant side, those are all in your textbooks on page 1104. And still looking at your textbook, in the second column on page 1104, I'm going to read from your book. It says, in the AWS American National Standard Symbol System, the joint is the basis of reference. Any welded joint indicated by a symbol will always have an arrow side and other side. Accordingly, the terms arrow side, other side, and both sides are used to locate the weld with respect to the joint. Another feature is the use of a tail of the reference line for giving the specifications for welding. The size and type of the weld is only part of the information needed to make the weld. The welding process, type, and brand of filler metal, whether or not you're going to be doing peening, chipping, or preheating, are also required. And other information must also be known. The specifications placed in the tail of the reference line usually conform to the practices of each company. If notations are not used, the tail of the symbol may be omitted. Sometimes you won't have to put a tail on there. Now we're on page 1105. What's the difference between a weld symbol and a welding symbol? A weld symbol indicates the type of weld, and it is usually part of a welding symbol, the overall welding symbol. So the welding symbol is the complete information needed to convey the necessary welding information to all parties. including the welder. It contains several different elements, including the weld symbol. So if you go back to our blackboard here, here we have a welding symbol, and we'll put a tail on it, and we'll say SMAW. And so this weld symbol might have 1/2 inch for the size of fillet weld there, and 3/8 inch for the size of fillet weld there. So these are all elements of the welding symbol. But the weld symbol that we're using is the symbol for a fillet weld. Earlier we showed the arrow side, other side, and no side significant slides. And in that we saw a V groove. So this would be the symbol for a V groove. We saw a J, single J. That is the symbol for a single J. So there's a lot of different weld symbols that go onto the welding symbol. Okay, so reading from your text, the AWS standard makes a distinction between the terms weld symbol and welding symbol. The weld symbol, figures 30-3 and 30-4, is the graphic symbol that indicates the weld required for the job. The assembled welding symbol, 30-5, consists of the following 8 elements, or as many of these elements as are necessary. However, only the reference line and arrow are required. So here are some weld symbols. This is figure 30-3 in your book. So here are weld symbols. Square groove butt joint, a scarf, a V groove, a bevel, a U groove, a J groove, a flare V, and a flare bevel. Down here we have the fillet weld symbol, a plug or slot symbol, a stud weld, and the stud weld is always on the bottom of the reference line, spot or projection welds, seam welds, back or backing welds, surfacing welds, and then edge welds. Again, that's figure 30.3 reading. Now the following consists of the following 8 elements, or as many of these elements as are necessary. However, the only ones that are required are the reference line and the arrow. So you can see we have a series of bulleted items there: reference line, arrow, basic weld symbols, dimensions and other data, supplementary symbols, finish symbols, tail, and other specifications. If you'll turn to page 1108, you'll find this. Now this is the elements of a standard welding symbol. And it looks pretty complicated, but it's not really. Now we know that we have to have a reference line. We know we have to have an arrow. But other than that, what do we have to have? Well, to really convey some information, you would have a weld symbol, and it could be on one side or the other side or on both sides. Then you're going to want some dimensioning information. If it's going to be a groove bevel, depth of bevel or the size or strength, groove weld size. F is for the finishing, what type of contour. It's going to be flat, it's going to be concave, convex, or flat. Groove angle, root opening. And since we're in Weld 1840, all of this information would be conveyed. Here we have the Weld AllAround symbol. If it's got a little flag in it, it means that it's going to be welded in the field, that is on the job site. Over here in the tail, the specification, process, or other type of a reference. It could refer you to a company's detail. So it may refer you to a detail drawing that you'll have to go to and read. And it says here that the tail may be omitted if it's not needed. Then we have the, if we're doing spots, the number of spots or seams or studs or projections, so forth. Elements in this area remain as shown when the tail and arrow are reversed, and the weld symbol shall be contained within the length of the reference line. Those are just a couple of notes on how you want to put these together. So that's what a weld symbol, welding symbol looks like, but as opposed to a weld symbol. Now go back again to page 1105, and you'll find this figure at the bottom. And what I wanted to point out here were these supplementary symbols here. This is a filled weld, and I talked about the break in the arrow. That's coming up again. We'll talk about that some more. Weld AllAround, So if you've got, for example, a piece of pipe going into a piece of plate, they want you to weld all around the piece of that pipe. This would be melt through. So if you're doing a groove weld, they want to make sure that you have some melt through on that. This is the symbol, and it is a square, not a rectangle, a square. This is a symbol for a consumable insert. That's normally associated with the gas tungsten arc welding process. Here we have a backing or a spacer, and that's rectangular. And you can tell the difference because here the backing is on the side of the reference line opposite whichever side the weld is going to be placed from. And here the spacer is in the center of the reference line. And then when I talked about contour, it's going to be flush or flat, and then concave or convex or concave. So those are supplementary symbols that you may have to use. And these things really aren't very confusing if you take a welding symbol one element at a time, start at the reference line, and work your way out. Breaking the arrow, I mentioned this before. You can see here we have the symbol for a bevel weld. Okay? And we don't know just from that symbol what side has to be prepared. So if you put a break in the arrow and then you point the arrow towards the side that needs to be prepared, we can see in cross-section that they want the upper side prepared. Now since the symbol is on the arrow side of the weld, we know that it's going to be prepared on the arrow side. If this symbol were up here, then it would come over and be prepared on this side. So let's go back to our book, see where we're at. Okay, we just talked about that. Now on the intervening pages, 1106 and 1107, this is the American Welding Society Standard Welding Symbols chart. All the information you need is on there, as well as some information in helping you to interpret the symbols. Let's see, where are we at? I have to pick this up on page 1105. I'm reading from where it says fillet welds and symbols. It says the fillet weld is a triangular shaped weld placed on the joint, not in the joint like a groove weld. The fillet weld symbol is also triangular in shape, so it is easily recognized. The vertical line of a fillet weld symbol is always drawn to the left of the symbol. The T and lap joints are most commonly welded with fillet welds. Figure 30.6 shows how the location, size, and length of a fillet weld are indicated on a welding symbol and a drawing. So symbols with a perpendicular leg shall have the perpendicular leg drawn on the left side of the symbol. That is a fillet weld, a bevel groove, a J groove, the flare bevel groove. Those will all, if it's got a straight line element, it will be drawn to the left. The symbols for stud and surfacing welds shall always be drawn below the reference line. So if you look here at our symbol that we've been working on, you can see that the straight line is on the left. The symbol for the J groove is on the left. If we had a single bevel, the straight line element of that would be drawn on the left. So it's always on the left-hand side. Keep that in mind because you may get that as a question on your test. Looking on page 1109, top of the page, you have this diagram in your text, and it says fillet weld size is shown to the left of the symbol. For double fillets, each is dimensioned. So here's the symbol that we're looking at. And you see we have an arrow, we have a reference, we have a fillet weld symbol, and the dimension 5/16. So that means we want a 5/16 fillet weld on the arrow side of the joint. And then if you look at it in weld cross-section, it's dimensioned it out. And sometimes you'll get a blueprint that actually draws it out for you and say, all right, we want a 5/16 weld and 5/16 weld, so there's no question that this is what you want. This is on that same page, fillet weld dimensioning. Now here, if you take a look at this, we have some additional information placed in the tail. 1/2 leg on member B. So member A is our vertical member, member B is our horizontal member, and then we have a fillet weld symbol and two different dimensions, 1/4 inch by 1/2 inch. So from this information that's here, and also the information identifying which member is which, we know that we want 1/2 of an inch of weld down here, but only 1/4 of an inch of weld up here. And if you notice, it corresponds with the thicknesses of the two different members. They're two different thicknesses, so they want a little more weld down on the thicker member. And again, in cross section, this is what it would look like. So it's got to be dimensioned in a manner that it's clear to whoever's looking at this. And if you just take your time, it makes perfect sense. So the fillet weld size for unequal leg fillets is shown to the left of the symbol, with clarifying information in the tail. This too is on that page. I believe it's the last figure on that page. The fillet weld length is shown to the right of the weld symbol. When fillet weld is to be the full length of the joint, no dimension is required. So if it's going to go the full length, we don't need to put that in there. But if we only want to go make a partial weld, then we have to put the length on there. So we have a fillet weld here, and again, it's going to be on the arrow side, and 12 inches of metal is going to be welded, but the remaining 3 inches are not going to be welded. So they want a 12-inch fillet weld, but they haven't told us how big a fillet weld. So this example is there strictly to show us how the dimensioning works. Okay, we'll get to intermittent fillet welds in just a moment. Let's go to your book. I'm reading from page 1108 still. And let's see. A sketch is shown to let you know how it would appear on the weldment. The size of a fillet weld is always shown to the left of the symbol, with the length always to the right of the symbol. So here on our sample, we have a 3/8 and a 1/2, and then we're going to put the length, say 3 inches, well, because we don't have to put the inch marks, and 4 inches. So that's how it would appear on a symbol. 1/2 inch fillet weld, arrow side, 4 inches long, 3/8 inch fillet weld, other side, 3 inches long, and we're going to weld it with shielded metal arc welding. Okay. If no length is indicated, the weld should run the full length of the joint. Figure 30-7 shows intermittent fillet welds as well as staggered fillet welds. When properly applied, fillet welds do not need to be large in size or necessarily run the full length of a joint. Let me see what slides I have for that here real quick. Don't remember if I had one. Yes, I do. Okay. First of all, let me read it from here. Now, an intermittent fillet weld is, as the name sounds, broken up, intermittent. We might have a 3-inch fillet weld, and then we'll skip a space and put in another 3-inch fillet weld, then skip a space, put in another 3-inch fillet weld. That would be an intermittent fillet weld. Now, the pitch, when they use the term pitch, that's the distance from center to center between those fillet welds. Now, chain or staggered fillet welds are also used. Now, staggered fillet weld would be just set in opposite. And I'll show you a slide of that. And then fillet weld finishing symbols are the same as for groove welds. But here, and here we have a T-joint, and these are chain intermittent fillet welds. So we have one here, 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 and the pitch, the distance from center to center, is 3 inches. Now, I don't know if you have this in your textbook or not. And then on this side, you can see that we have 2 inches. The welds are 2 inches long, but they're 3 inches from center to center. So that means there's 1 inch between each one. Chain intermittent weld dimensions are to be placed on both sides of reference line and opposite each other. So here we have the square groove, and it shows that we have a 2-inch weld, and they're going to be 3 inches from center to center. Now here we have staggered intermittent welds. Now if you look at the symbol here, all they do is they take the welding symbol, the weld symbol, and they just offset it a little bit. So we have a square groove, 3 and 10. So that means that the weld is going to be 3 inches long, and center to center is going to be 10 inches. And since they're staggered, you can see that it works out that it's actually only 5 inches. 5 inches from that center, to 5 inches to that center, to 5 inches to that center, to 5 inches to that center. Staying on one side, though, would be 10 inches to 10 inches, 10 inches to 10 inches, and they're all going to be 3 inches long. So this is your tip-off. If you see them offset in the weld symbol, welding symbol, then you know that they're going to be staggered intermittent welds. Pitch is the distance between centers of adjacent weld segments. Pitch length is shown to the right of the weld length dimension following by a hyphen. So 3-inch welds 6 inches apart. Okay? All righty, let's see what we have next. Okay, with the Weld All-Around symbol, that's at the top of page 1108, second column. And this slide that I have on the board, that is on page 1110. It's the very last item. It's figure 30-8. So you have the same one in your textbook. And here we have the Weld All-Around symbol. They used to use a dot, but too many people mistook that dot. Let's see, they used the dot, I believe it was, for the for a filled weld. And people used to mistake the dot right there at the junction of the arrow and the reference line as a Weld All-Around symbol. But that used to be their filled weld symbol. Now they've gone to a flag to dispel that confusion. At any rate, a circle at this junction indicates that you have to weld it all the way around. And here are some examples of how they've welded it all around. Here is what needs to be welded. And here's section AA looking on it. And then this is what it looks like welded all the way around on that. Weld All-Around symbol is a very useful symbol. Multi-plane weld requirements are very simple to sketch using a symbol. Okay. So what we're looking at here on this detail, if you were to take this and turn it like this, that's what you're looking at. And so you can see from this how big this piece is. This is the same piece. Turn it sideways, and this piece is this piece. So we're just looking at it at 90 degrees apart, and you can see how it's welded. So know your Weld All-Around symbol. Then, let's see, what's next? Yeah, I threw this in here to show the filled weld and Weld All-Around symbols. Here they're used in combination with one another. And here we have multiple reference lines, and we'll get to this a little bit more later on. But essentially it means you're going to do this process first. So you're going to do a single bevel, single V-groove first, weld all the way around. It's going to be welded in the field. Then when you're all done, you're going to examine it using UT. That would be the second process. So this is what's done first. This is what's done second. Okay, page 1108, groove welds. There are 7 types of groove welds and symbols to represent them. So there's square, scarf, V, bevel, U, J, flare V, and flare bevel. I believe your textbook has eliminated the scarf one. But these are the different types of groove welds. And here it says groove welds, there's 8 types. Your textbook says there's 7 types. So I believe your textbook has done away with the scarf. Groove weld dimensions. Well, how do you dimension that? Well, first of all, you need to know that a groove weld is placed in a joint, while a fillet weld is placed on a joint. Okay? Then drop down to where it says figure 30-9, shows the symbol for a V-groove weld in a butt joint. To properly read and interpret a groove symbol, start with the information found in the groove symbol and then work from the reference line out. So, let's get rid of this symbol, and we'll draw another one up there. So here's our reference line again. Here's our arrow again. And this time we'll have, this is a groove weld symbol. And if we have a piece of material like this, we could have it pointing like that. Arrow side if it was arrow side, it means that the work would actually be done over here. And since it's a single V, we would know that both members would need to be prepared. So you don't have to put a break in the arrow to show that, because we know it's going to be the arrow side, which would be the other side. So we're going to start reading from the reference line out, but first of all, let's read from your book. It says, the first thing the welder must do in setting the joint up is to set the root opening. And the root opening is placed within the weld symbol or just outside and only on one side of the reference line. Inches or millimeters per shop practice. So here we have a flare bevel, and they want a 1/32 root opening. Here they show us a single V, and they want a 3 millimeter root opening. That 3 millimeters is not quite 1/8 of an inch, so we're going to go with 1/8 of an inch. So on our example, we would put 1/8 of an inch right there. Next, the second thing would be to verify the groove angle. And it says this angle is 60 degrees, so each plate must be beveled, have a bevel angle of 30 degrees. The dimensions to the left of the groove weld symbol give the groove depth and the weld size. They are read from left to right. The first thing the welder must do when setting this joint up is to verify the depth of the groove. Once this and the root opening have been set, the weld can be made. In this case, the depth of penetration beyond the groove is 1/8 of an inch. So we're looking again at figure 30.9, which is on page 1111, and they have drawn it. Let me just draw what they have. They have drawn a single bevel with no root opening at all, with a 60-degree angle, and they call this an included angle. If you were to extend this on out, the angle from here to here would be 60 degrees, which means if you do a straight line, the bevel angle would be half of that, or 30 degrees. So each one of these is beveled at 30 degrees, but the included or overall angle is 60 degrees. And if they're showing us, they're showing that depth of preparation there is 3/8 of an inch, and the groove weld size is 1/2 of an inch. So over here they're giving us depth of preparation, 3/8, and then in parentheses, 1/2, like so. So therefore, we know that they're looking for 1/8 of an inch of penetration into the parent metal. Let's see, what do we have next? If you look at these slides over here, the groove angle is placed just outside the symbol of the weld. So we have 60 degrees, 10 degrees, 40 degrees, and here we have a single V groove symbol. This would be a double U groove single because we have a single U on each side. And then here we have a single bevel. And again, note that we have a break in the arrow. So the break in the arrow would be pointing towards whichever member they wanted to have prepared. So here's some dimensioning. I think these are similar to what you have in your book. Perhaps not identical, but similar. Here we have an example. This is the Weldon cross-section. Up here it has a 1/4 inch bevel preparation and a 3/8 inch weld. So again, they're looking to get an 1/8 of an inch penetration into the parent metal. This would be a single V. I don't know how well you can see that. Here we have a double V, and they are looking for, again, a 1/4 inch bevel preparation, but then a 3/8 inch weld. So again, they're looking for an 1/8 of an inch joint penetration. And here, again, we have another double V groove, and here they're working on thinner metal so that it's all going to blend together and they'll have a solid weld all the way. These are called partial penetration welds because, as you can see, it doesn't extend all the way through the base metal. And here we have a complete penetration. And typically they would also put in here, in the welding symbol, they'd probably have a tail there that would say, well, let's do some back gouging or back grinding in order to achieve that. And you can also look at the drawing and tell that this weld was put in first and then this weld was put in second. So this would be, the upper one then would be a back weld, or it would have been applied secondarily. Okay. Length. Now, before I get ahead of myself, let's read here. I'm reading from the center of the column on page 1110. It says, Figure 3010 is a symbol for a double V groove weld. If a groove weld is not dimensioned for depth and size, the joint shall be prepared and the weld shall be made to ensure complete joint penetration. So note those initials, CJP, complete joint penetration. Everything that you're doing in Weld 1840 is with complete joint penetration. And figure 3010 is off to the right-hand side. And that's just what I was talking about on the board with my other slide. Again, my slides don't match up with your textbook quite exactly, but the examples are similar. Drop down a couple of sentences and highlight where it says, since groove welds and butt joints are typically used in highly critical applications, they generally will be required to run the full length of the joint. Drop down a little bit further, it says, if a groove weld length is required, it will be shown to the right of the groove weld symbol. If no length is shown, the weld shall be made the full length. And this is what my slide here on the board shows you. Here we've got two pieces of pipe, and I've actually run into this. I've had to do inspection. Imagine these standing vertically up. And these are called stitch welds. And what it is, here's this welding symbol for a flare bevel groove, because both of these pipes are rounded, and that's what the rounding of the weld symbol shows. And so they have to have a weld 16 inches long, 8 inches from the end. And my job was to go in, and when these things are in a power plant, they tend to crack right near the toe, right here. And they'll actually start pulling parent metal away from the tubes as they're in service for a long time. So in this case, they would say, well, we want a weld of a specific length. And so on the blueprint, then you would see that they want a 16-inch weld 8 inches from the end there. And so if they do have to give you a dimension, they're going to give it to you to the right of the symbol. So the length of the weld shall be placed to the right of the weld symbol. No dimension is required if the weld is to be continuous for the entire length. Okay. Let's see, what's next? Here's some examples of 43. The flare bevel or flare V grooves are unusual in that they take their shape from the structural member that we are going to be welding on. Those pipes that I just showed you, that constitutes, if we have, looking down on the end of it, if we have two pipes sitting together like that, you can just see from the roundness of the pipe that would make a flare bevel. And that's where they get their name from. In this case, the round bar makes a flare in the bevel, which will make it difficult for the welder to get the heat of the process into the root of the joint. And they are talking about, let's see, figure 3011. Yeah, so I have that right here. You have the same thing in your book, and it's this one right here. This is your figure 30-11. It's the same thing. And looking at that, if you read the notes, it says, notes, variable E denotes the groove weld size. The depth of the bevel S equals the radius of the round member. So they can punch in whatever numbers they need to there to accurately account for the dimensioning of that. So they've just substituted letters instead of dimensions in this example. And so this would be a single flare bevel because one side is straight and the other side is rounded. But on the symbol, remember, the symbol, the straight line, has to be on the left-hand side. So they still draw it with the symbol on the left-hand side and then the bevel on the other side. And you'll notice that the symbol is written beneath the reference line. Therefore, the weld is going to be made on the arrow side, which would be the upper side here. Now, I know it sounds confusing, but it's really not. Just take it one element at a time, and you'll get it. Next, we have edge welds. This is page 1111. I'm going to read from your book. The edge weld is a weld that totally consumes the full thickness of the edge of the joint it is being applied to. It is typically used on edge joints, flanged butt joints, or flanged corner joints. And it says figure 30-12 represents some various examples of edge welds. My slide here says basically the same thing. Edge welds, used to specify edge welds on edge joints and flanged butt or flanged corner joints. Their full thickness of joint members must be fused the size is to the left of the symbol, and the length and pitch is to the right, and they may be continuous or intermittent types of welds. Here's a welding symbol for those. This is your figure 30-13. It's very similar to that at any rate. This, my example doesn't have any dimensioning on it. Let's see, that one's not going to do us any good there. So, thought I had a slide that showed me those. Bear with me one moment while I back up. No, I'm sorry. I thought I had some that would explain that a little more clearly, but apparently I don't. If you look at 3012, and at the top one, A, what we have is an edge weld, and it could be two pieces of metal coming down together like this. Or it could be a flared flange coming down like that. In any event, we have a square edge here, and that might run off like so. That might run off like so. So this is an edge weld. And your weld would be deposited right here. In our book, your example, A, shows that the symbol as 1/8 inch and 1/8 inch, like so. And then we have, right below, we have the melt-through symbol. And there's a difference now. You notice that the melt-through symbol is black, okay? That's to distinguish it from a back weld. If you'll flip, let me see, where did we pass that at? If you'll flip back to figure 30-3 on page 1105, you can see that a back weld is clear, but a melt-through symbol is darkened. It's colored in. That's how you tell the difference. Also on page 1106, where it says American Welding Society Standard Welding Symbols, on page 1106, you can see the melt-through symbol is darkened in. Let's see, where's the back weld symbol? Whereas on a page 1107, you can see the back weld symbol is clear. So know that distinction. They color it in for a reason, okay? So if it's colored in, if that little crown there is colored in, you know it means melt through. They want you to melt all the way through the material. And of course, we're talking about real thin stuff here. You know, you could get a melt through symbol. Say you wanted to make a weld like this. Say this was 1/4 inch thick plate, okay? And you had a welding symbol that came like this, and this would be a square groove. And since the arrow side is here, but on the back side they might do a melt through symbol. So they're telling you that they want you to take this piece of 1/4 inch steel and make a square groove butt joint, but they want to make sure that you melt all the way through like that. And so your melt through is actually here on the other side, and then there's your weld. So again, if they darken it up, you know that they want you to get all the way through there. Okay. Combined welding symbols. Contour. Your book doesn't really get into combined symbols very much, but let me just talk about them real quick. Here, this is my symbol that we don't have any dimensioning on, but again, you can tell with the straight line on the sides, we know that this would be a fillet weld. See the triangle? And this would be a single bevel and a fillet weld, okay? And here we would have a single J and a fillet weld. When you're reading these things, you always start at the reference line and work out. So let me just draw this real quickly for you. And what kind of a weld would that be describing? Well, if I can find my chalk, I'll show you. So let's take the one on the left-hand side. And that symbol looks like this. Oops, my mistake. Okay, so we have a fillet weld, a single bevel, and a fillet weld. Well, that's probably going to be applied to a T-joint, like that. And so I'll come down here where I can make it a little bit better. So looking at our weld, well, we know that on the arrow side, which would be this side, we would want a fillet weld. Yes? Okay. This is pointing towards the arrow side. Therefore, on the other side, back over here, we want a V groove. So we would put a V groove, a single V groove, and that would be a weld. But then on top of that, our last operation, reading from the reference line out, would be another fillet weld. So there's what we have. Okay? So you got, this is what the preparation would look like. That's what your two pieces of steel would look like before you began welding. Fillet weld, single bevel, fillet weld. Fillet weld, single bevel, fillet weld. And that's the way you read them. The other one's just the same, with the exception that you're doing a single J on that one. So one element at a time, start at the reference line, read out. Contouring symbols. Weld contours and finishing. Figure 314, upper right-hand corner of the next page. You can look at these. And we have C means chipping, G means grinding, H means hammering, M means machining, R means rolling. And you're going to have symbols that would go flat, concave, or convex. So weld surfaces can be contoured to several shapes. Convex, that's where it's sunk in. Concave, that's where it's crowned. And then flush or flat. So you're going to have the symbols, as shown in your text. If it's going to be a concave or concave, it's going to have a slight crown on it. Convex, it's going to be sunken in. And flat, of course, is going to be flat. And then there's different types of finishing. And in here, let's take a look at this symbol we have. Okay, here we have a single V groove with a back weld. Remember, the back weld is clear. So a single V groove with a back weld, and then they have this symbol right above it. It's a straight line, which means they want it flat. Here they want it flat. So they want both of the surfaces to be flat, and you're going to do that by machining. M is for machining. Here, they have a fillet weld, and they want it flat, but they want you to make it flat by grinding. And that's the way you would read those. They're really pretty simple. But pay attention to those. That's figure 30.14 in your textbook, so that you can understand what chipping is, what grinding is, what machining is. Or U for unspecified. If you look at the symbol here for unspecified, they want a single bevel, and they want to take it down flat, but they don't care how you do it, so they use unspecified for that. And my slide doesn't have a U for unspecified, but that's what they do with it. Okay, applications of welding symbols. If you drop down to the bottom paragraph in that topic, it says, a non-destructive examination symbol has several elements. Take a look at figure 3015, which shows elements and how they are located with respect to each other. If you look at figure 3015, you can see it's very much like a welding symbol. Whoops. Yeah, there we go. Very much like a welding symbol. In this case, the flag means you're going to examine it in the field. Examine all around. It's got an arrow pointed to where they want it done. The length of the examination. If you're going to be doing UT or RT, how much of it are you going to, if you've got a pipe that's 3 feet in diameter, well, that's a circumference of almost 10 feet. How much of that 10 feet are you going to x-ray? And this is what the symbols will tell you. Here we have examine all around symbols. Field examination, so you're not going to do it in the shop. And this is the symbol for radiation. And this line right here that the longer arrow that they have coming out from that line shows you the reference. It will direct the reference. Where are you going to place your source in reference to the object that's being X-rayed? And that's what that one is for. And then finally, these abbreviations, read them over. They're in your book. And get a handle on what they mean. AET, ET, LT, MT, NRT, PT, PRT, RT, UT, and VT. AET is acoustic emission. ET is electromagnetic. L is leak testing. MT is magnetic particle. Neutron radiographic, penetrant, proof, radiographic, ultrasonic, and visual. The ones that I really want you to focus on, the ones that are most commonly done, are leak testing, mag particle testing, dye penetrant testing, X-ray, ultrasonic testing, and visual. Those are the most important ones. Those are the ones that are used a bunch. Let's see, I have something here that says miscellaneous. We looked at this slide before, and it says welding and NDE symbols can be combined on the same reference line or on separate multiple reference lines. If you get a symbol that has more than one reference line, what you do is you start closest to the arrow and work back. So the first thing we would do is we would make our single bevel. Okay? You make the weld, right? And then the next operation would be to UT it, ultrasonic testing on it. So always start near the arrow and work back. Oops, that slide's all messed up. Most of these aren't in your book. I wanted to put them in there, so just a few things I want you to know about. Again, on multiple reference lines. First operation, second operation, third operation. So here we have, let me draw this on the board real quick, and I'll do it right here where you can see the symbol at the same time. So we have a symbol for a back weld, a symbol for a single bevel, and then a fillet weld with a flat finish. Can you see that pretty good? Okay, so what we have then, and of course we have the arrow which shows us where it's going to break at. So what we have is, let's see, that's going to be on the other side. So we were going to have a back weld here, and then we are going to have a single bevel here, and then we're going to put a fillet weld out on top of it like that, and we're going to finish that thing flat. So you've got basically another T-joint, and here's your back weld, here's your single bevel, and here's your fillet weld. So we did the back weld first, then we did the single bevel weld, then we did the fillet weld, and we took it down flat or flush operations 1, 2, and 3. Again, starting at the arrow and working back away from it. Multiple reference lines. One operation at a time. And here's what it says. 2 or more reference lines may be used to indicate a sequence of operations. First operation is always on the reference line nearest to the arrow. And then one last thing I wanted to point out to you. These look kind of crazy, I know, but here we have more than one arrow. And you might see a symbol with more than one arrow, but it's going to be pointing to a part or parts where they want you to apply these welds. So you can't have more than one arrow, okay? But don't let it confuse you. If the symbol is on the arrow side, you're still going to put it on wherever the arrow side is. If it's on the other side, you'll put the weld on where the other side is. Okay. Now I want you to review what we've talked about, highlight those things that we've discussed, play this tape again if you need to. If anything's not clear, get with me, and watch the training videos that go along with this. They're going to go more in depth. It's a 40-minute film, and they'll go more in depth about how to read and interpret welding symbols. And that should prep you pretty good for the test on this chapter. And it should also set you up for a better understanding of welding symbols when we get into welding inspection technology. Thank you very much.